All right, let's dive right into this explainer. Today, we're unpacking a really fascinating defense strategy that essentially blends the courtroom with the laboratory. Now, usually, the law relies on things like past precedents or human intent. But in this case, we are using statistical physics and complex network science to challenge some pretty fundamental legal assumptions about internet virality. It's a completely different, mathematically driven way to measure cause and effect, and honestly, it's pretty mind-blowing.
So specifically, we're looking at a case involving a man, let's just call him Dr. Chen. Now, Dr. Chen had under 100 followers and basically zero account interaction, yet he is legally accused of causing a severe disruption of public order. And legally speaking, that implies widespread chaos, systemic breakdown, massive societal impact. The catch? He allegedly triggered all of this with a single retweet, which brings us to a really profound question about cause and effect in our hyperconnected world. Can one tiny, practically invisible action actually cause a system-wide avalanche?
To understand exactly how the defense breaks this down, we're going to use a zoom-out structure. We'll quickly cover law meets physics, the micro-level dying spark, the meso-level invisible node, the macro-level avalanche trigger, noise versus phase transition, and finally, reevaluating legal causation.
Okay, jumping right into part 1, law meets physics, the legal anomaly. Let's look at the actual intersection of criminal law and network science in the charges against Dr. Chen.
So, according to the prosecution, this totally isolated action from an account with virtually no reach somehow created massive societal chaos. And that is a massive assumption, right? Because it completely bypasses the actual mechanics of how information travels. The prosecution is basically taking a microscopic origin point and linking it directly to a macroscopic disaster without showing any of the work in between. And it's exactly this assumption that the defense puts to the test, using established physical laws to see if it actually holds up to scientific scrutiny. Moving on to part 2, micro, the dying spark. Let's look through our first scientific lens, the micro level, to see how information actually transmits. To understand just a single retweet, the defense models the action using something called the Galton-Watson process. This is a mathematical framework that scientists traditionally use to predict how populations, or in our case, a piece of information, will either cascade and grow or just quickly go extinct over successive generations. It's kind of like a biological virus, right? If the conditions aren't right and the host doesn't interact with enough vulnerable people, the virus doesn't start a pandemic. It literally just hits a dead end and fades away.
And the math here reveals a pretty stark reality. Because Dr. Chen had less than 100 followers and almost no engagement history, his expected average branching rate, also known as the R0, is just 0.05. In physics, an R0 that incredibly low places the event in a deeply subcritical state. That means for every retweet, the next generation of retweets is expected to be a fraction of the last. So, mathematically speaking, a cascade isn't just unlikely, it's practically impossible. The spark dies almost immediately.
Now, to put that into perspective, the legal threshold for severe disruption often requires a massive scale. We're talking upwards of 500 retweets just to hit the baseline for a crime. But the mathematical expectation for Dr. Chen's subcritical post, it totals out to about 1.05 retweets. 1.05! That is an enormous 500-fold gap between the legal requirement and the mathematical reality of what is essentially a dying spark. The defense argues that prosecuting someone based on this mathematical expectation is literally like arresting someone for causing a flood when they only spilt a single drop of water.
Let's zoom out a bit to part 3, Meso, the invisible node. We need to look at the actual architecture of the internet to see exactly where a user like this sits within the wider web.
You see, social networks aren't these flat, egalitarian grids where everyone has the exact same megaphone. They're what physicists call scale-free networks. And that basically means the flow of information is characterized by severe inequality. It's entirely dictated by a few massive superusers, the hubs. Think of your major celebrities or massive news organizations with tens of millions of followers. Those are the hubs. Meanwhile, the silent majority, everyday users with a few dozen friends, sits out on this long, disconnected peripheral tail. They have almost no structural impact on the overall flow. And Dr. Chen represents one of those peripheral nodes. According to network science, specifically a concept known as Cohen's threshold formula, these peripheral nodes are structurally invisible. What does that mean? It means that within the vast mathematical topology of the network, whether this node is there or not doesn't change how the network functions. Deleting them or having them become active with a single retweet has near zero impact on the system's overall robustness. They just do not have the connections to influence the hubs.
So, from a network engineering perspective, the defense is arguing that a peripheral user literally cannot structurally crash the system. The architecture of the web simply doesn't allow a node that isolated to bypass the massive hubs and single-handedly cause a system-wide disruption. The math just does not support the idea that a user with minimal connections can force a global change in the network. No way.
Zooming out even further to part 4, macro, the Avalanche trigger. If Dr. Chen didn't crash the system, how do complex systems actually crash?
Well, this brings us to a really cool concept called self-organized criticality, or SOC. This property explains how massive system-wide disruptions actually happen in the real world. It suggests that complex systems naturally evolve over time toward a highly unstable, critical state. It doesn't just happen overnight. Slowly, day by day, underlying tensions and pressures build up within the structure of the system itself, pushing it closer and closer to an invisible tipping point, where even the tiniest perturbation can unleash total chaos.
The absolute best way to visualize this is through physicist Per Bach's famous sand pile model. Just imagine a pile of sand. During the accumulation phase, you drop grains one by one over a really long period, and nothing happens. But eventually, the entire pile reaches this incredibly steep, unstable, critical state. At that exact point, one single, completely random grain of sand falls and, boom, it triggers a massive avalanche. The defense argues that when an avalanche happens, it's not because that final individual grain of sand was magically powerful. It happens because the entire pile was already dangerously unstable and completely primed to collapse.
Which leads us perfectly into part 5, noise versus phase transition. To really cement this defense argument, we have to translate the physics of that sand avalanche back into the terminology of social order and ultimately the courtroom.
Let's walk through this mapping methodically because it's super important. First, we have the fluctuation, or thermal noise in physics. In the digital realm, that's our single isolated retweet. Next, the phase transition, like ice melting or our sand avalanche. That maps directly to a severe public order disruption. Finally, the critical state of a system. That represents systemic social tension that is already present in the background. The defense is arguing that the prosecution is committing a massive category error here. They're looking at a system-wide phase transition and blaming it on a normal, micro-level fluctuation, instead of actually examining the critical state of the system itself.
And there's actually a scientific rule for this dynamic. It's called the fluctuation dissipation theorem. Yeah, it's a bit of a mouthful, but the principle is clear. A system's response to a tiny external force is entirely dictated by the system's own internal volatility and structural readiness. So, translated to our legal case, the defense's stance is essentially this. If a tiny, almost invisible whisper appears to cause a massive riot, the true cause of the riot is the extreme pre-existing tension of the system just waiting to explode, not the whisper itself. Okay, part 6, reevaluating legal causation. Let's bring all of this complex physics firmly back down to earth, into the courtroom, and focus on the fundamental legal concept of causation.
The defense really highlights that the prosecution has completely failed to provide data proving a verified causal chain. They haven't proven the network was already in a critical state, they haven't proven Dr. Chen's retweet somehow magically breached the massive network hubs, and there is absolutely zero proof of a sustained cascade. By simply pointing the finger at Dr. Chen, the defense argues the prosecution is committing the micro-macro fallacy. In a legal context, that means improperly attributing a massive macro-level societal event to a micro-level insignificant action. It's essentially blaming normal, everyday background noise for a system-wide earthquake without any connecting scientific evidence.
The absolutely crucial point from the defense here is that you cannot just use the butterfly effect as a shortcut to skip the heavy burden of legal proof. The butterfly effect is a great scientific metaphor for chaos theory, sure, but it's a reminder that catchy phrases we use in everyday life don't always hold up under the strict, rigorous scrutiny of legal proof. It is definitely not a valid legal mechanism to bypass demonstrating actual, measurable causation.
Which leaves us with this really fascinating, provocative thought about complex systems and the law. When things break down, when a society experiences severe disruption, do we blame the invisible, dying spark, or do we look at the highly combustible, structurally fragile environment it fell into? It entirely shifts how we think about responsibility, evidence, and causation in the digital age. Thank you so much for joining me for this explainer. I really hope it gave you a new lens to look at the invisible networks all around us.